I decided to do my project on atomic clocks and deep space navigation based on two articles found from NASA. Before talking about atomic clocks, I think it's important to understand how normal clocks work. So, most modern clocks, from wristwatches to those used on some satellites, keep time using a quartz crystal oscillator. These devices take advantage of the fact that quartz crystals vibrate at a precise frequency when voltage is applied to them. These vibrations of crystals act like a pendulum in a grandfather clock, ticking off how much time has passed. The problem with these clocks is that sometimes we just need more precision. To determine a spacecraft's distance from Earth, navigators send a signal to the spacecraft, which then returns it to Earth. The time the signal requires to make that two-way journey reveals the spacecraft's distance from Earth, because the signal travels at a known speed, the speed of light. To know the spacecraft's position within a meter, navigators need clocks with precision time resolution, clocks that can measure billionths of a second. For this application, quartz crystal oscillator clocks will not be precise enough. The solution to this lack of precision are atomic clocks. Atomic clocks combine quartz crystal oscillators with an ensemble of atoms to achieve greater stability. Every GPS device and smartphone determines its location via atomic clocks on satellites orbiting Earth. The satellite sends signals from space, and the receiver triangulates your position by measuring how long the signal takes to reach your GPS. While being much more precise than normal clocks, atomic clocks still have their limitations. Currently, spacecraft flying beyond Earth's orbit don't have GPS to find their way through space. Atomic clocks on GPS satellites aren't accurate enough to send directions to spacecraft, when being off by even less than a second could mean missing a planet by miles. Instead, navigators use giant antennas on Earth to send a signal to spacecraft, which bounces it back to Earth. Extremely precise clocks on the ground measure how long it takes the signal to make it this two-way journey. The amount of time tells them how far away the spacecraft is and how fast it's going. Only then can navigators send directions to the spacecraft telling it where to go. This two-way navigation means that no matter how deep into space a mission goes, it still has to wait for a signal carrying commands to cross the vast distances between planets. Even though the speed of light is very fast, these vast distances cause very noticeable delays. Depending on where Earth and Mars are in their orbits, it can take anywhere from 4 to 20 minutes for a one-way signal to travel between planets. These limitations are the inspiration for NASA's new deep space atomic clock. NASA's goal is to build an atomic clock small enough to fly in a mission, but precise enough to give accurate directions. This could eliminate the need for a two-way system. The deep space atomic clock uses mercury ions. These mercury ions have an electric charge, meaning they can be contained in an electromagnetic trap, which prevent interactions with the vacuum chamber walls from happening, allowing the deep space atomic clock to achieve a new level of precision. And this is a picture of the what it looks like, and it's around the size of a small toaster. There are many benefits to this new technology that NASA is developing. Because spacecraft would no longer have to wait for signal instructions from Earth, autonomous navigation would be much more feasible. Having a clock on board would enable radio navigation. This, combined with optical navigation, make for a more accurate and safe way for astronauts to be able to navigate themselves. One-way navigation has applications for Mars and beyond. DSN antennas would be able to communicate with multiple missions at a time, broadcasting one signal into space. The new technology could improve the accuracy of GPS on Earth, and multiple spacecraft with deep space atomic clocks could orbit Mars, creating a GPS-like network that would give directions to robots and humans on the surface. Tests of this new technology have been a resounding success, giving hope that it will aid human exploration of space. NASA completed its 2-year test of the device and is currently working on a version 2 that will hopefully go on missions to places like Venus and Mars soon. These are my sources. Thank you.